So, Tori, thank you for joining us, somewhat against your will. I see you brought a turtle with you.
Yeah, this is my pet sea turtle. His name is Finn.
Did you know that sea turtles technically have flippers, not fins?
Did you know that this YouTube channel is technically called Learning with Legos, not criticizing other people's choice of pet names?
That is an excellent point, yes. Well, I know math terrifies you. You threw that in there at the end of the last video. But how do you feel about organizing things?
What do you mean?
Like, if I gave you an object and asked you to put it into two different groups that it could belong to based on its characteristics, could you do that?
Sure, that sounds easy.
Okay, and what if that object were actually a number?
Then that would sound too much like math, and Finn and I would be out of here.
No, wait. I'll do all the math, I promise. You just have to stay and help with labels.
Let me consult with my protege.
You know that sea turtles can't talk, right?
You know that you're the one who wants our help, right?
Another good point. Consult away.
Fine. We'll stay.
You mean Finn will stay? Get the joke? Because his name is Finn. It's funny, right? Your dismissive silence indicates otherwise. Okay. Let me start reading the problem. Chris bought 10.4 gallons of gasoline. What groups would you put that 10.4 in?
Well, I could put that in a group called gallons of gasoline, because that's what it is.
Perfect. So you're just using the clues that were word clues, and they came after the number. What other group, a second group, could you put that in? What would you say if I asked you that?
I would say that this is math, and we're leaving.
No, it's not math. Look, you found word clues after the number. So go ahead and look before the number. What other word clues do you see?
Well, this says Chris bought. So I could also put this in a group called Things Chris Bought.
Awesome. So I can put this number in the top left corner of a box. So I'm going to have an imaginary box that's going to be sitting right here. It's going to have split into 4 parts: top left, top right, bottom left, bottom right. The 10.4, when I put it here, is going to be on top. And so I'm going to call this top gallons. That was the first thing you labeled for me. And then it's also on the left. So I'm going to call the left Things Chris Bought. And I'll just put Chris Bought. So, we've got that so far. And because it's gallons and Things Chris Bought, we're going to put it where gallons and Things Chris Bought intersect.
Okay, that sounds reasonable.
So as we read the rest of the problem, we're just looking for a number that fits either of those two categories. So either a gallon that we could put on top, or something else Chris bought that we could put on the left. So this next part here says there are approximately 3.8 liters in 1 gallon. So what will that 3.8 be?
Well, liters, obviously.
Good. So that's not the same as gallons, which means we're not going to put it on the bottom. And it's also not something Chris bought. So here we have gallons compared to liters, top and bottom. Left and right, we're going to have Chris bought compared to what, Tori?
Compared to there are?
Sure, yeah, that's a word clue that'll work. If we want to be technical, we would say that because this is something that's just plain true, it is, in math, a conversion factor.
Which is why there is no way on earth that I am using that word.
Okay, so we'll just put the word are. These are things that are. And you told me the liters match the 3.8, so I'm not going to put that on top where the gallons are. I'm going to put the 3.8 on bottom. I'm going to put the 1 on top. Gallons are still on top. Liters are on the bottom. And let's see, the last thing I need to do is put the what are. So it asked me what measurement is closest to the number of liters, bottom, that Chris bought left. I don't know this yet, that's why they're asking. And so now I'm just going to do something called the butterfly method.
Woohoo! Actually, I can participate in this. Well, Finn can. He does a great butterfly impression.
Really? All right. Well, have him hop over here and lie down on top of that equal sign for me. I don't know if we need all of you. Here, Finn, why don't you stay here? Oh, you are good at the butterfly impression. Look, you're even making butterfly sounds, which is to say no sound at all. So, what I am going to do here is I'm going to take my bottom right side and connect it to my top left side. And in the butterfly method, we're connecting everything using multiplication. So this becomes 3.8 times 10.4. And then the bottom left times the top right is going to be x times 1, which we know we could write 1x. But if there's only one x, I can also just write the x, because that's what it is. So, thank you very much. You can go ahead and scoot out of here, Flipper.
His name is Finn.
Right, Finn. So, I've got x by itself. This is amazing. All I have to do is multiply these, and I'm done. Now, my test taker extraordinaires, you know that about 4 times about 10 is going to be about 40. You'd be done already. If you need to prove it, then you can go ahead and write out the actual multiplication. I've got 10.4 times 3.8. In multiplication, I don't care about lining up the decimal. This one just happened to work that way. I always line up the leftmost digits. And then 8 times 4 is 32, right? The 2 carry the 30. 8 times 0 is nothing, plus 3 is 3. 8 times 1 is 8. Done with that. Done with that whole place value. 3 times 4 is 12, carry the 1. 3 times 0 is nothing, plus the 1 that I carried. 3 times 1 is 3. And I'm going to get here 2 plus nothing, 3 plus 2, 8 plus 1, 3 plus nothing. And I have 2 numbers to the right of the decimal here. So I need 2 numbers to the right of the decimal here. Exactly what we thought it should be. Well, are you all willing to stick around for the next problem?
Yes.
Okay. The distance, let me scoot this down so we can see it. All right. The distance between two towns is 120 kilometers. I need 2 different labels for that 120 kilometers. What do you got for me?
I've got kilometers and distance between 2 towns.
Okay, kilometers and distance. You'll notice Tori's more of a word person, so when she says distance, we're just going to write a D. Total math trick. And that's where the 120 goes. The next thing is approximately, right here, there are approximately 8 kilometers in 5 miles. So, what do we do with those?
We're going to put that on the right side, and 8 is kilometers. So that can go on the top with the other kilometers. And then 5 goes on the bottom because it's miles.
Awesome. So we've got kilometers on top, miles on bottom. And then we also have distance on the left. And this next part didn't describe a distance. We know that that was a conversion factor.
I heard that.
That was just what things are. So the 8 and the 5 are together on the right side. I didn't say it out loud, but when we have this box filled out, it's really just 2 fractions equal to each other. And then what's going to go in the bottom left here, Tori?
We put a T there.
Not an X.
Can you spell turtle with an X?
Not Very well, no. Okay, so there is a T, an unknown number of miles, that's the distance between the two towns. The distance in kilometers I do know, the distance in miles I don't, but now that I know a different thing about miles and kilometers, I've got this all set up and ready for the butterfly. So, Finn, you can come on back and do your butterfly impression again. What does the butterfly method do, Tori?
It takes the bottom right and the top left and it multiplies them.
Look at you sneaking a math word there without even panicking. Okay. And then what next?
And then the bottom left times the top right and multiplies them.
Okay. And so I don't have to write the times sign here. I'm just going to have the 8 with the T. Anytime a number and letter are written next to each other, it's a secret hidden multiplication problem. And do you want to go ahead and solve that for us, Tori? We're going to take your stunned silence as a definite no. Blatant refusal. All right, so I have 8 times T. I'm going to solve this using opposite operations. The opposite of multiplying by 8 is dividing by 8. And if I do that to one side, I'm going to do that to both sides. Now, here's a cool trick. Instead of multiplying these earlier, or even right now, and then dividing, check and see if you can just divide this part right here. 120 divided by 8, well, 8 can go into 12 one time, and there'll be 4 left over, which means 15 times 8 is 120. So that's like simplifying a fraction. The 120 and the divided by 8 just became a 15. The times sign is still there. So when I have T by itself, because those 8s cancel, T equals 15 times 5. Now, if you know your multiplication facts, you know that 5 times 5 is going to end in a 5. And if you weren't sure, we could prove it. 15 times 5. 5 times 5 is 25. 5 times 1 plus those 2 we carried. Boom. All right. You up for one more?
Sure. But then I have to get back to the ocean and find Finn some dinner. I only came here because I figured that following a giant talking cheese would lead me to giant sandwiches. But there are none here, so Finn and I are both hungry.
All right. Well, we'll do this one quickly. And what do sea turtles eat, by the way?
Sea turtle food, obviously.
Obviously. That is so obvious. Okay. So you're perfect if you stay right there. And I'm going to read here. Some doctors recommend that men drink 3 liters of water every day. There are approximately 29.6 milliliters in 1 fluid ounce, which measurement is closest to the number of fluid ounces in 3 liters. What do we do here?
You put 3 in the top left because it's the first number we see.
Awesome.
And then you label it 2 different things. In this case, the labels will be liters and water that men drink every day.
Water men drink. Wow. Every time you take over, there's a lot more words than I would have put. That's good, though. The next part says there are approximately 29.6 milliliters in 1 fluid ounce. How do you feel about that?
I feel like I've been lied to because you said I wouldn't have to do math. But I know that to get to milliliters, to be liters, you would have to do math. So, bye.
But bye? Wait, no. Okay, bye. Thanks for helping. Let this be a lesson to you, children. Don't lie to sea turtles or their friends. That is true. The liters and milliliters don't technically already match, but this is a conversion that should be so easy that you shouldn't have to count it as math. If I want to change both of those to liters, I certainly could. What's actually going to be easier here is if I change the liters to milliliters, because 3 liters is going to be 3,000 milliliters. There's 1,000 milliliters in every single liter. So now I have milliliters on the left, which means 3,000 on top, 29.6 on bottom. And then that's going to be the same as what? Well, it says here which measurement is closest to the number of fluid ounces. So I don't know how many fluid ounces there are, but these two numbers are related with my conversion factor, which I guess I can say now that Tori's gone. The conversion factor here is 29.6 milliliters in, and now I know my labels for the right side, 1 fluid ounce. So butterfly these up. I've got 1 times 3,000 here, which is just going to be 3,000. I've got 29.6x technically, but here it says closest. So let's make our lives easy, and let's just say 3,000 equals 30x. Opposite operations, same thing. The opposite of multiplying by 30 is dividing by 30. So I cancel out a 0. I got 300 divided by 3. X should be about 100. And there we are. So there is your newfound butterfly technique. And best of luck to you. Happy mathing.